Hi there. So today we're going to take a look at organic compounds that have hydrocarbon derivatives. In particular, we'll look at alcohols and halides today. And in the next video, I will do one with esters and carboxylic acids. So here's just showing that we do have some hydrocarbon derivatives. So we have some functional groups, and we've gone through in another video some alkenes and alkynes. And what makes them a functional group is that you'll have that double or that triple bond between carbons. Now today we're going to look at alcohols and halides. And if you have an alcohol, it just means you have an OH somewhere along your carbon chain. And if you have a halide, it just means you have a halogen somewhere on your carbon chain. And then there's ways to name them. So looking at the first one, we know we have an alcohol because we have this OH group on the carbon. And now when you have these derivatives, they are going to take precedent when it comes to numbering your carbons. So they're going to always be attached to the lowest number possible. So numbering my carbons, I'll have carbon 1, 2, 3, 4. So this compound would be bute. So butane for 4, butane. And then it would be 1 all, showing that your alcohol group is on carbon 1. In the second example, similar, you still have 4 carbons. We're still going to number from left, that would be from right to left, giving the OH group on carbon 2. So just very similar. So you have butane, so bute, and then this time would be 2 all. Moving on to the next one, we took a look at what makes a benzene ring. So when you have that 6 carbon ring with alternating double bonds, if you have an OH on it, it's just called phenyl. So I tell my students you just have to have that memorized. With this next one, we now have a couple of our branched side groups on our main chain, but your longest chain will contain the OH group. So the OH is connected to carbon 1, and then we'll name or number the rest, and then we have carbon 7. So your longest chain has 7 carbons, and your alcohol is on carbon 1. On carbon 3 and on carbon 5, you have 2 methyl groups. So 2, you'll write di, and then methyl. And then we'll have hept, 1 all. Our next one is bringing in a cyclic hydrocarbon when we have 4. And carbon 1 will have the OH group. So this will just be cyclo, showing that your carbons are connected, butanol. We don't have to say where the OH group is because it's assumed to be on carbon 1. I included this slide because a lot of the times tests and questions will still ask you about properties. And unlike alkanes, alkenes, and alkynes, alcohols are a polar molecule because of that hydroxyl group. So that OH group on your chain having some lone pairs will make your molecule polar. So because of that, it can be dissolved in, mixed with water, right? Unlike the alkanes, alkenes, and alkynes. And then just a few more points. So as your chain becomes longer, your alcohol becomes less soluble. And that's just because your chain is essentially overpowering it, because most of your chain is going to be non-polar. So if that little polar part is still there, the longer your chain gets, the less that will matter. Your boiling points are higher because of that hydrogen bonding. So because of this OH group, you have hydrogen bonding forces. You'd also have dipole-dipole and LDF, which having all 3 makes higher boiling points. And then about this last one, I think that they're all toxic. Now here's an old diploma question, and now that we've covered alkenes, alkanes, alkynes, and now alcohols, we should be able to do this question. So asking which compound is an alkene, you're just looking for the ending ENE. So that would be carbon 1. Which is an alcohol, we need something that ends in OH, so that would be number 6. Containing a triple bond, you need a YNE, that would be number 4. And this last one is cyclic and saturated. So to be cyclic, you must see the word cyclo. To be saturated, you have to end in ANE. So this would be number 5. Here's another example, and I like to put more than one like this just to show how repetitive these diploma questions can get. But we're still doing the same thing. Identify alkyne. We need a triple bond, so that would be number 4. Identify an alcohol. We need an OH on your main chain, so number 6. Aromatic, you need to see benzene, so 1. And an unsaturated hydrocarbon. There are more than one choice here, and if you were writing, say, the Alberta diploma, more than one would be accepted. So to be unsaturated, you need to see a double or a triple bond on your main chain. So 3 or 4 could work here. I'm just going to put in 3. Okay. Now moving on to alkyl halides, that's when you have a halogen on your main chain. And that halogen will again take precedence when it comes to numbering. So we have, also the halogens are named a little bit differently. So instead of calling chlorine, you call it chloro. Fluorine becomes fluoro, bromine, bromo, iodine, iodo. So we're still numbering our carbons. So on this first example, we have carbon 1, carbon 2, carbon 3, and on carbon 2, you have your bromo group. So I'd write this out, 2 bromo, and then 3 carbons would be propane, and there's no double or triple bonds, so this is just 2 bromo propane. Okay. Looking at our next one, we have our 1, 2, 3, 4, 5, 6 carbons, and I want to start numbering from left to right to give my smallest number 3. If I've started from this carbon over here, I'd have carbon 1, 2, 3, 4. So because going from left to right gave me 3, I'm going to have to number that way. Now 6 means hexane. On carbon 3 you have a fluorine, so this would be 3 fluoro hexane. Sorry, my brain is getting super messy. So ANE, because it's all single bonds. Now there is an extra rule here, and that is if you do have more than one halogen, you must use a prefix in front. So like the di, tri, and so on. So taking a look at this, and your halogens will get the lowest number. So I'm going to start 1, 2, 3, 4, 5, 6. I just want to double check if I went this other way. I'd have 1, 2, 3, 4, 5, which would make my numbers bigger. So I'm numbering clockwise. So here on carbon 4, I have a methyl group. And then on carbon 1 and 2, I have 2 bromos, so dibromo. My carbons are all connected, so cyclo. And then there's 6 of them, so hexane, hexane, for all single bonds. Okay. Going and taking a look at when it gets a little bit harder, and that is when you have more than one halogen. And if you do, you write them alphabetically. There is this note, if you do have a multiplier like di, tri, and so on, don't consider them with the alphabet, just consider your halogens. So with example A, I am going to number from left to right. And I do have chloro and fluoro to place. Chloral, alphabetically, C will be before F. So I would write this out, 2, 3, dichloro. Then I have on carbon 4, fluoro. And then my 6 carbons in my main chain would be hexane. So they're getting a little longer. My next one, I'm going to number from right to left to give my smallest number possible. And on carbon 2 and 4, I have bromo, which I'm going to name first because bromo will come before chloral. So 2, 4, dibromo. And then 3, chloro. 6 carbons would be hex, and then all single bonds, so hexane. Now, my very last one, I have a cyclic hydrocarbon with bromine and chlorine. So I'm going to give bromine carbon 1, and then it wouldn't matter what direction I went because either way, I'd get chlorine on carbon 3. So this one would be 1 bromo, 3 chloro, And then so I'm just running out of room. So then my next part would be cyclo, because they're all connected, and then butane, because butane is 4, ane, because all single bonds. And now this last little bit, just drawing it out. So if I wanted to draw out bromoethane, ethane means 2 carbons. Bromo means there's just one, and it doesn't matter which one you pick because either way it would be the same molecule. So I'll just put it on carbon 1, bromine, and then I would fill the rest with hydrogens. Okay. The next one is a little bit more complicated, and because it's longer, heptane means 7. Let's do that line diagram. So starting at your first point is 1 carbon. So 1, 2, 3, 4, 5, 6, 7. And then putting your groups. So on carbon 2, 3, and 4, you're putting iodine. And that tri just means there's 3 of them. So carbon 2 needs an iodine. Carbon 3 needs an iodine. And carbon 4 needs an iodine. Also on carbon 3, you have a methyl group, which is just shown with a straight line. And then all of your hydrogens are still there. They're just implied because of the line diagram. Here is ending off with just another old diploma question going through now that we know all of that. So if we want an alcohol, our alcohol has that OH connected to the carbon on a main chain. And I know some of you might be tempted to pick number 3, but you will notice when we do our next video, or if you've done organic before, that that's actually a carboxylic acid. So it's tempting to pick because you do see that OH group, but it's not going to be that one. It will be number 4. Then if something is aromatic, you need to see the benzene ring. So number 2. Carboxylic acid was number 3, so that's sneaking its way in even though we haven't done it yet. And halogenated hydrocarbon, we just need to see halogens, which is also, again, on carbon 2. As always, if you found this helpful, please subscribe and give me a like. If I can help you with anything else, just leave me a comment. Thank you.